Hello, this is CIT 371, Linux System Administration. In this lecture, I'm going to be talking about monitoring management. So this lecture is being provided to give you all an overview of monitoring, including its benefits, purpose, and management methods. I should note that a lot of the concepts in this lecture will apply to multiple systems, not just Linux, but of course we're going to go over some monitoring software for Linux to make sure it's system specific for this course. I'm also going to introduce the Uptime Kuma container that you're going to be using. So, as a note, hopefully you finished the Docker lab and Docker was working okay, because you're going to need to use it for this software's container. To end the lab, we're going to be talking about to end the lecture, we're going to be talking about the monitoring management lab. So, in the context of IT, the term monitoring refers to the gathering of data concerning a company's hardware and software. So I want to note that I pulled a lot of information from this and next few slides about monitoring from this article from TechTarget. So the process of monitoring is used to verify that applications, computers, network equipment, and other components are working as expected. So monitoring is typically performed by an application, but some hardware devices dedicated types of monitoring exist. One example is an intrusion detection system, which monitors the ingress, uh, traffic ingress and egress, looking for anything suspicious. So types of monitoring can have varying levels of detail, from a simple device checking or simple device operation checks to granular observations of the performance of a computer's components. I should note that you may think that, wow, this is awfully similar to logging, and that is true. Logging and monitoring are pretty related. They're fairly related to one another. So logging actually is a type of monitoring. So logging is one way to get information from applications and systems, um, and collect that information in a file. It's basically a form of monitoring. Logging is a form of monitoring. So why would we want to monitor? So monitoring is critical for any IT environment because it helps with the proactive response to problems. So it basically helps you catch problems as they happen and respond to them immediately. This is important for the following areas. Monitoring is very important for security because when we monitor devices, network traffic, file systems, and account usage, it can help us discover malicious activity that can threaten the organization. This is especially important for the confidentiality and integrity of data and systems. Monitoring also ties to availability because we can monitor how healthy a system is and its performance. This lets us know when a system is down or at risk of going offline due to failing components or having any other issue that would cause disruptions. Finally, there's performance. Monitoring can help us analyze the system's performance. One thing we can do with this kind of monitoring is create a baseline for what normal traffic is and normal system usage is. This can help us identify when a device is being overworked, when there's an abnormal amount of network traffic, or when the system is in need of new components. Now, there's also multiple types of monitoring. There's real-time monitoring. It is the continuous collection of data to determine the current and ongoing status of monitoring targets. There are two subcategories of real-time monitoring. There's reactive, that occurs after a specific event or issue occurs. In other words, we're monitoring systems and applications and so forth after a security event happens. And then there's proactive monitoring where we're constantly doing it whether or not an event has happened. This is to catch an event in the act. Historical monitoring uses past data to discover trends. This can help identify anomalies related to threats to security or availability. There's point-in-time monitoring that focuses on a specific instant or event to identify a problem that demands immediate attention. There's time series monitoring. It's based on recurring events over a period of time to determine what is normal behavior. Linux actually has a lot of different monitoring, a lot of monitoring software that's available by default and that you can install through a package manager or by source or whatever. Here's some examples. We've already talked about a few earlier in the class, but top basically lets you monitor processes in real time. PS command just provides a snapshot of running processes. Yeah, top will constantly update while it's running. PS just provides a static view of what processes are running. VMstat monitors processes, memory, paging, and CPU. IOStat is a command that's used to show statistics for CPU and file system input-output. And then what we covered in the network system and troubleshooting lab, or the network configuration troubleshooting lab, is netstat, or SS, which lets us see statistics on network connections, interfaces, and routing tables. As I noted before, the SS command is the updated version of netstat. Now here's two other programs. There's Monet and Nagios. Monet used to be taught in a really old version of 470, but it's for CIT 470, but it's an open source monitoring software that is used to monitor Linux systems, services, file systems, and system resources. It could What's interesting about it, it could actually attempt to restart services, programs, and daemons if they end up being discovered, or if Mnemonic finds that they're in a down state. It can also check the life of other systems, so it can actually send a ping test to check if a host is alive. It uses its own language to configure it. If you want to learn more, I provide a link here on Monet's official website. Then there's Nagios. It's a lot more robust than Monet, but it's a lot more complicated to configure. It focuses on identifying issues in organization IT environments. Monet probably won't be used in an organization, or at least not a large one. Nagios probably will. Nagios is actually capable of monitoring systems, applications, services, business processes, and network protocols. This can even include custom programs and services made specifically by a company. And now we're not going to teach Monet or Nagios in the sense of actually implementing them in this class, but there is Uptime Kuma, which we are going to use. It's a simple monitoring tool that is self-hosted in a Docker container. It doesn't support intrusion monitoring, but it does allow us to track the uptime of web pages. Basically, all it's for is to track uptime, hence the name. So it checks if like web pages, Docker containers, servers, and other things are up and running. Now it does this with tests, such as HTTP connection tests for like websites, do ping tests for hosts, and also even DNS records it can check for. So by default, when you run the container, it's available at if you type in the IP address of your VM, or just type localhost and then :3001, that's the 3001 support it's running on, you can access the Uptime Kuma web page hosted by your Docker container. So the tool can send you notifications via Telegram, Discord, email, and other tools. Now the tool is typically run in a Docker container, but you can natively install it on Linux. We'll say we're going to use it as a container in this class. Okie dokie, the lab overview. So you're going to actually install and use the following monitoring tools. These are ones, other than Uptime Kuma, I didn't mention these other three. They're HTOP, Nmon, and then Glances. You'll need to install these first three on your Ubuntu server, and then you run a container of Uptime Kuma on the rest of the lab. And then you're going to spend the rest of the time paying close attention to the resource instructions I've given the lab to set up Uptime Kuma. I've given a number of tips. I just ask that you pay close attention to them. If you don't configure Uptime Kuma correctly, it can not work. And if it doesn't work, you will need to delete it and remove it. Of note, please make sure your Apache container is running, and if it's not, you need to rebuild it by going back to the previous lab. You can list your containers with docker ps-a and then run docker start and then the container ID of your Apache container to run that one in case it's not. But that should be everything you'll need to know for the lab. But thank you very much for watching. I appreciate your time. If you need any help understanding anything I've talked about in the lecture, or if you need help in the lab, please let me know. But thank you very much for your time again, and have a wonderful day.